Okay, I want you to close your eyes for a second, but, only if you're not driving. Please don't do that. And just picture a single word. It's a word that strikes this absolute terror into the hearts of computer science students.
Oh, I know exactly where you're going with this.
Right. It makes seasoned developers just roll their eyes, pack up their laptops, and look for the nearest exit. It's probably the single biggest reason people take one look at a language like Haskell, scream, and then run right back to the comfort of Python or JavaScript.
You are talking about the M word.
I am. The monad.
The monad. It sounds like a villain from some, cheap 1950s sci-fi movie. The monad is coming for your code base. Run for your lives.
It really does have that reputation. It's infamous. And the worst part is, if you're brave enough to even ask someone to explain it, they usually push up their glasses and start quoting category theory.
Ugh.
They say things like, oh, it's actually very simple. A monad is just a monoid in the category of endofunctors.
Which is, it's technically true, but it's helpful to absolutely no one who is just trying to get a program to work.
Exactly. It's like asking how to make a sandwich and getting a lecture on the molecular structure of yeast. And that is exactly why we are here today. We are doing a deep dive into a brand new post that dropped literally today, January 21st, 2026, from a blog called qianmeng.org.
Okay.
The title is Notes on Haskell Programming, Part 77, on Understanding the Practicality of Monad.
Part 37. Wow.
Yeah.
That is some serious commitment to the bit.
It is. But here's the hook, and this is why I picked this source. The author, Eng, he doesn't call himself a computer scientist or some, mathematical theorist. He calls himself an old software plumber.
I love that. Software plumber.
Me too. It suggests we aren't getting the ivory tower lecture today. We're getting the blue-collar rolled-up sleeves version. We're going down into the basement, looking at the pipes, and, trying to figure out why the toilet is leaking.
And honestly, that is the best way to understand monads. You have to strip away all the math and just look at the plumbing.
So that is our mission. We're going to tackle the maybe monad and this weirdly named bind operator, but we're going to do it using Eng's very practical plumber-style analogies. We're going to figure out why, despite the terrifying name, this tool is actually a lifesaver for keeping your code from exploding.
I'm ready. Let's get our hands dirty.
Okay, so let's unpack this. Eng starts the post with a complaint that I think resonates with anyone who has ever tried to learn a complex topic online. He says he's read so many explanations of monads, and they are all rather too technical.
Right, and he makes a really keen observation here. He says that because monads come from category theory, the heavy math stuff, people feel obligated to explain them as math. But he points out that when you try to apply those strict definitions to, say, non-functional languages, it often just exposes more complexity.
Yeah, it's like explaining a car engine by starting with the laws of thermodynamics instead of just telling me which pedal makes it go vroom.
Precisely. It creates a barrier.
Yeah.
It makes you feel like you need a PhD just to handle a simple error message. So Eng just cuts through all that noise. He synthesizes a definition that is actually useful for a working programmer. In the context of functional languages like Haskell, monads are used to handle side effects.
Side effects. Okay, so in medicine, a side effect is what happens when you take an aspirin for a headache and suddenly your stomach hurts. It's the unintended consequence. What do we talk about in code?
It's actually not that different. In functional programming, the ideal is a pure function. Think of it like a perfect math equation. If you put in 2 plus 2, you always get 4. It doesn't change anything else in the universe.
Right.
It doesn't print to a screen, it doesn't save a file, it doesn't check the time, and it definitely doesn't launch a missile.
Okay. But a program that never prints anything, never saves anything, and never launches anything is, well, it's basically a space heater. It just warms up the CPU.
Exactly. You need to interact with the messy real world to make software useful. And that interaction, that messiness, is the side effect. Eng lists 3 big ones. Input-output, like reading a file. State, like changing a variable. And the big one for today? Errors.
So if I try to divide by 0, or I try to open a file that doesn't exist, that's a side effect.
In this context, yeah. It's something that disrupts that pure, perfect flow of logic. And Eng's whole point is that monads are the tool or the plumbing that we use to handle those disruptions so the rest of the code stays clean.
Keeping the code clean. That is the plumber mindset right there. You want the water to flow through the pipes. You don't want it leaking all over the bathroom floor.
Exactly. If the water leaks, you have a mess. If an error leaks into your main logic, your whole program crashes.
So let's look at the specific tool Eng brings out of his toolbox for this. He focuses on the maybe monad, and he uses that classic analogy. The box.
The box is universal for a reason. Imagine you have a value, let's just say the number 5. In a normal language like Python or Java, you just have the number 5. But in Haskell, with the maybe monad, you wrap that 5 inside a context. You put it in a box.
Okay, so I have a physical box sitting on the table.
Right, and this specific type of box, the maybe box, it has a rule printed on the side. It tells you about the existence of the value. So it creates a context where a value might be there, or the box might just be totally empty.
So if I peek inside, I either see the number 5,
Which Haskell calls just 5, just, meaning, here is just the value.
or I look inside and it's empty.
Right, which is called nothing.
Just or nothing, so it's binary.
It seems trivial, right? Like,
Right.
why bother putting the number in a box? Why not just use the number?
Yeah, it feels like extra packaging.
Yeah.
I get enough Amazon boxes as it is. Yeah, I really don't need more boxes in my code.
But think about error handling. If you're expecting a number, but you get, well, nothing, what usually happens? Your program crashes. Null pointer exception, segmentation fault, the screen goes blue.
Ugh. The blue screen of death. The nightmare of every user.
So by putting it in the box, you're creating a safety wrapper. You're saying, I'm handing you a container. It might have a value in it, it might not. But you can hold the container safely either way.
Okay, I think I follow that. It's like handling radioactive material. You don't hold the uranium with your bare hands. You hold the lead box. Even if the box is empty, the box itself is safe to handle.
That's a very intense analogy, but yes, the box protects the system from the uncertainty of what's inside.
So Eng sets up this box analogy, but then he throws a curveball. He shows us a snippet of code that looks a little weird. He starts with this, just +1.
Just +1.
So we have a box, but inside the box isn't a number, it's a function, +1.
Yes. In Haskell, functions are treated just like data. You can put a function in a box just as easily as you can put a number or some text. So here we have a maybe box containing the instruction add 1.
Okay, sticking with the analogy.
Okay.
I have a box, and inside is a little slip of paper that says add 1 to whatever you find.
Correct.
Now, this is where the plumbing gets real. Eng introduces a symbol. It looks like 2 arrows and an equal sign.
The bind operator.
Eng calls it the pipe function. And I feel like this operator is like the protagonist of the whole story. If the monad is the box, what is this thing?
If the monad is the box, the bind operator is the machine that knows how to open it.
The opener.
It's actually more than just an opener. It's a processor. Eng breaks it down, and it basically does 3, maybe 4 things in a sequence. Imagine a little automated machine on a factory line. Step 1, it takes the box.
Okay.
Step 2, it unwraps it. It takes the value out. Step 3, it feeds that value into a function to do some work. And then, and this is real important, step 4, it wraps the result back up into a new box.
Unwraps, calculates, rewraps.
Exactly. Unwraps, calculates, rewraps. It handles the context. It handles the transition from box to unbox and back again, so you don't have to get your hands dirty with it.
Okay, so it's an automated unboxing machine. That sounds convenient. But Eng shows us a specific example that proves this isn't just about convenience, it's about survival. He shows a chain of code using this operator.
The short circuit example. This is the key.
Okay, I'm going to read the code out. Bear with me, listeners. We're going to visualize this. It starts with just +1. That's our box with a +1 function,
Right.
then the bind operator.
Right.
Then it pipes it into F. Then another bind operator. Then nothing. Then another bind operator piping into X. And finally, return XX.
It looks like a riddle written in alien hieroglyphics.
It really does. So let's trace it like Eng does. We start with the first box, just +1. The bind operator takes that +1 function out and names it F.
Right. So in our system's memory, F is now the instruction add 1. We're good so far. The machine has unwrapped the first box successfully.
Then we move down the pipe.
Mm-hmm.
We get to the next value. But the value is nothing.
An empty box.
And we're trying to pipe this empty box into a variable called X.
Okay, now stop and think. If you were doing this manually and you tried to take a value out of an empty box to do math with it, what would happen?
I'd reach in, grasp air, panic, and the universe would implode. Or at least my script would crash.
Exactly. But the bind operator is smart. It knows the rules of the maybe game. When it looks at that box and sees nothing, it doesn't panic. It doesn't try to run the next function. it short circuits.
Short circuits, as in it just stops.
It cuts the power to that whole logic chain. It stops the entire process right then and there. It says, look, there's no value here. I can't do any math on nothing. So the result of this whole entire chain is just nothing.
Wait, so what happens to that last part of the code, the return FX part where it was supposed to actually do the math?
It's a ghost. It never happens. The computer never even looks at it.
And that's incredibly slick.
It is, because look at what just happened. You encountered an error, a missing value, and the system handled it gracefully, stopped the calculation, and returned a safe error result, the nothing box, without you writing a single line of error-checking code.
I didn't have to write, if the box is empty, then stop.
Nope. The operator did that for you. It just absorbed the error.
This is what Ang means by keeping the code clean. The logic of add 1 to this number is what you care about. The logic of check if the box is empty, that's the plumbing. And the monad hides the plumbing in the walls.
Perfectly put. You want to live in the house. You don't want to live inside the pipes.
But to really drive this home, Ang does something kind of cruel. He shows us what life looks like without the monad.
Ah, the manual nightmare.
He calls this function apply function manual. And just looking at the shape of the code on the page, it's ugly. It's like a staircase of text. It's indentation hell.
It's the pyramid of boom, yeah. It's often called callback hell in other languages like JavaScript.
So describe what's happening there for our listeners.
Well, without the bind operator to automatically unwrap things, you have to do it all yourself. So you have to write a case statement. You have to say, case boxed funka now, and then you have to handle the failure. If it's nothing, return nothing. Then you handle the success. If it's just, but wait, you're not done. Now you have the second value. So inside that success block, you have to open another case statement. Case boxed val of.
Oh, no.
If that is nothing, return nothing. If that is just X, then finally you can do the math.
It's exhausting just listening to you describe it. I feel like I need a flowchart just to read 5 lines of that code.
It's total micromanagement. You are manually checking every single step for failure. And did you notice the repetition? Return nothing, return nothing, return nothing. You're repeating your error handling logic over and over and over again.
And if you forget one of those checks.
If you forget one, your program crashes. If you indent it wrong, syntax error. It's brittle, it's hard to read, and it buries the actual logic, the simple add one, under all these layers of defensive code.
So the difference is just dark. The monad version is a straight line. Take this, pipety here, done. The manual version is this zigzagging mess of if this, then maybe that, but if not.
Yes. And this is why Ang, our software plumber, appreciates the monad. It's not because he loves category theory. It's because he hates fixing leaks manually.
That makes so much sense. It's just pragmatic. It's laziness in the absolute best possible way. Let the tool do the hard work.
It is.
I want to pivot a little bit to the author himself, Ang, because reading this post, I got a really distinct vibe from him. This is part 37 of his Notes on Haskell, part 37.
The man has stamina. I mean, Haskell is not an easy language to stick with for 37 installments.
But he writes at the end, and I think this is so important. He says, we'll revisit this in the future once I'm starting to grok the concept later through writing more Haskell code.
Grok. That's such a classic sci-fi term from Heinlein. It means to understand something so intuitively that it becomes part of you. You don't just know it. You kind of are it.
And he admits he's not there yet. He's writing this to figure it out for himself. He says, I'm understanding this through my writing.
And that is such a healthy attitude, especially in tech. So often tech blogs are written with this tone of absolute authority. I am the expert, sit down and listen. Ang is basically saying, I am a learner, come walk with me on this.
Exactly. And it's not just Haskell. Did you look at the sidebar on his blog?
I did. It's delightful.
He has notes on gardening, notes on fish keeping, notes on dieting, notes on photography.
He's a tinkerer, a systems thinker.
I feel like there's a connection there. I mean, take fish keeping. I don't know much about it, but isn't that basically maintaining a biological computer?
Oh, absolutely. An aquarium is a closed-loop system. You have inputs, food, light. You have outputs, waste. You have side effects, algae growth, pH spikes. And if you just throw fish in water without understanding the nitrogen cycle, they die.
The nitrogen cycle is the monad of the fish tank.
In a way, yes. It's the background process that handles all the toxic waste, the side effects, so the fish can just live. If you fight the cycle, you crash the tank. If you work with it, it flourishes.
I bet that mindset helps him with Haskell. He's used to being patient. He knows you can't just force nature or, the Haskell compiler to do what you want. You have to understand the rules of the system.
And he understands that learning is iterative. He breaks things down into notes. He revisits them. He doesn't expect to understand the maybe monad perfectly on day one, just like you don't grow a perfect garden on day one.
It really takes the pressure off. I think a lot of people give up on things like functional programming because they hit that wall of math and just think, well, I'm not smart enough. Ang is showing us, no, you just need to work through the plumbing until it clicks.
And you need to feel the pain of the alternative.
What do you mean by that?
Well, think about his manual nightmare example. You can't really appreciate the elegance of the monad until you have sat there staring at a screen, writing your 10th nested case statement, and just thinking, there has to be a better way.
You have to suffer the plumbing problem before you're willing to buy the better pipe.
Exactly. If you just show a beginner the operator, it looks like cryptic nonsense. It looks like a typo. But if you show it to someone who has been fighting with manual error checks for a week, it looks like a miracle.
That's a really powerful insight. It's the why before the how.
Always.
So let's bring this all back together. We've dug through the plumbing of qianmeng.org. What are the key nuggets we're taking away?
Okay, first, the definition. Monads aren't these scary math monsters. In practice, they're tools for handling side effects like errors to keep your main logic clean and pure.
Check.
Second, the analogy. Maybe monad is just a box. It might have a value just, or it might be empty, nothing. It's a context wrapper that makes handling that data safe.
Simple enough.
Third, the tool. The bind operator is the automated pipe. It unwraps the value, processes it, and wraps it back up for you.
The unboxing machine.
And finally, and this is the most important part, the safety. It short circuits. If it hits a nothing, it stops the chain safely.
Yep.
It handles the error automatically so you don't have to write the pyramid of doom.
And that saves us from the manual nightmare.
Precisely. It turns a zigzag mess of checks into a straight line of logic.
So what does this mean for you, listening? Maybe you aren't a coder. Maybe you never plan to touch Haskell. But I think there's a broader lesson here about abstraction.
I agree. It's about recognizing the plumbing in your own work. What are the repetitive, messy tasks you do just to keep things from breaking?
The error checking of daily life.
Right. Are you manually checking 5 different spreadsheets to make sure a date is correct? That's a manual case statement. That's a side effect you're managing by hand.
And the goal should be to build a system, a monad, for your workflow that handles that for you, so you can focus on the actual work and not just the checking.
Exactly. We all need better abstraction so we can focus on the stuff that actually matters.
And maybe we need to be a bit more like Ang, patient with our learning, willing to admit we're still grokking it.
And willing to share our notes, even if we aren't experts yet. That transparency is so valuable.
I love that. So here's a final provocative thought for you to chew on. Ang needed 37 blog posts to get to this realization about monads. 37 steps of struggle and study.
It's a journey.
It suggests that true understanding isn't about memorizing a definition. It's about experiencing the pain of the manual method so you can truly appreciate the solution. So look at your own life. Where are you currently feeling the pain of a manual process? Because that pain, that's just the signal that you are ready for a monad.
Find your systems.
Find your systems, build your boxes. And hey, maybe check out Ang's notes on gardening while you're at it. Thanks for diving in with us today.
Always a pleasure.
We'll see you on the next deep dive. Stay curious.